Hey everyone, welcome back to the channel. So in today's video, we're going to take a deep look at one of the most powerful and modern development boards available right now, the ESP32-S3 Development Board. Whether you're a complete beginner just starting out or someone who has already worked with ESP32 and now wants to move into camera, USB or AI projects, this video is for you. So before we jump into coding, camera or USB features, let's first understand the hardware of this board properly. Because once you know the hardware, everything else becomes very easy. Now let's start with the most important part of the board. The shiny metal module right here. This is the ESP32-S3 room module. This module is basically the brain of the entire board. And now, just like the classic ESP32, this metal cover is not just for looks. It acts as a heat sink and also as an RF shield. So when Wi-Fi, Bluetooth or USB is running, this shield helps reduce heat and also protects the signals from external interference. And on the same metallic shield, you can see N16R8, which tells us the internal memory configuration of this ESP32-S3 chip. Here, N16 means the chip has 16 megabytes of flash memory, and R8 means it has 8 megabytes of PSRAM integrated inside the package. Now let me remove this. Quick warning though, don't try to remove this shield unless you really know what you're doing. Inside this metal shield is the actual ESP32-S3 chip along with flash memory and in some variants external PSRAM as well. Inside this module, we have a dual-core processor that can run up to 240 MHz with built-in Wi-Fi and Bluetooth. But the big upgrade with ESP32-S3 is that it's specially designed for USB, camera, and AI-based applications. That's why you'll see features on this board that were not available on older ESP32 boards. Now, one of the most important features of this ESP32-S3 board is the camera connector. Right at the center of the board, we can see this camera connector. This is a 24-pin FPC camera interface, which allows us to directly connect several OV series camera modules. Now, near the USB ports, we have two important buttons. The first one is the boot button, and the second one is the reset button. The reset button simply restarts the board. So whenever your code gets stuck or you want to restart the program, you can just press the reset button. The boot button is mainly used while flashing or uploading new firmware. For now, you don't need to worry too much about it. We'll use it step by step in future videos. On the board, you'll also notice a few indicator LEDs. There is a power LED that shows the board is on. And there are TX and RX LEDs that blink during serial communication. So whenever data is being sent or received, you'll see these LEDs blinking. The board also has an LED connected to a GPIO pin, which means you can control it directly from your code. And along with that, there is an onboard RGB LED, which is also connected to a pin on the board. Now, on the same board, you'll notice that we actually have two USB ports. The first one is the USB-OTG port. This USB port is directly connected to the ESP32-S3 chip itself. That means this port supports native USB communication. Using this port, the ESP32-S3 can work as a USB device, like a keyboard, mouse, or even a USB audio device. It also allows direct programming without any external USB to serial converter. This is a big advantage of ESP32-S3 compared to older ESP32 boards. The second USB port is the USB-UART port, which uses CH343P USB to serial chip. This port is mainly used for uploading code and also for serial monitoring and debugging. So depending on your use case, you can use either USB-OTG or USB-UART. Now if we turn the board to the backside, we can see some important components here. First, we have the 1117 3.3 voltage regulator. This regulator converts the 5 volts coming from the USB into a stable 3.3 volts. And this 3.3 volts is required by the ESP32-S3 and other components on the board. Next to it, we have a 100 microfarad tantalum capacitor. This capacitor helps in smoothing the power supply. It also provides stability, especially when the camera or Wi-Fi draws sudden current. Here we can also see the CH343P chip, which is the USB to serial converter. This chip allows the board to communicate with your computer for programming and serial monitoring. Apart from this, there are some supporting components for the camera interface. These components help in signal stability and proper communication with the camera module. And finally, on the backside itself, we have a micro SD card slot. This allows us to store images, videos, logs, or any other data directly on an SD card. And here you can see the pin symbol notations, which show whether a pin is used for the camera, SD card, or PSRAM. Alright, now let's talk about the pins on this board. If you look along both sides of the ESP32-S3 Development Board, you'll see long rows of pins. On this board, we have 20 pins on each side, so all the important GPIOs are broken out neatly. These pins are called GPIO pins, which stands for General Purpose Input Output. And this is how the ESP32-S3 talks to the outside world. Using these GPIO pins, we can do a lot of things. We can read a button press. We can turn an LED on or off. We can control a motor, or we can connect sensors, displays, and other external modules. Now, if you look closely at the pin labels, you'll see some power pins as well. Here you can see the 5-volt pin. This means you can drive 5 volts from the board to external devices. And you can also give 5 volts externally to this pin in case you are not powering the board using USB. Next to that, we have the 3V pin. This provides a stable 3.3 volts, which you can use to power external sensors or modules. And here we have ground pin. Now, here's something very important to notice. Some of the pins on the side headers are actually connected to the camera interface. If you look closely at the board, you'll notice a symbol printed below these pins. These pins are reserved for camera signals. So when you're using a camera module, make sure you do not use these pins for any other purpose. Using them incorrectly can damage either the board or the camera module. Now, similar to the camera pins, you'll also notice some pins on the header marked with another symbol. These pins are connected to the onboard micro SD card slot. Internally, these pins are used for SD card communication. So when you are using the SD card, these GPIO pins are already in use. You should avoid connecting any other external components to these pins at the same time. So if you are not using the camera or SD card, then those pins can be reused, but only if you clearly know what you are doing. Here we can see the complete pin diagram of the board. Now, similar to the camera and SD card pins, here are 3 more pins on the same header that are actually connected to the PSRAM. And honestly, this is one of those things that confuses a lot of beginners. So let's clear it up properly. You might have noticed this on your ESP32-S3 Development Board. Apart from the flash chip, you can see only one main chip, which is the ESP32-S3 itself, sitting inside that metal shield. So then you look at the board specifications and it clearly says 8 megabytes PSRAM. And naturally, the question comes up, okay, so where exactly is the PSRAM? So here's the answer. Some ESP32-S3 variants come with in-package PSRAM. Now, what does in-package PSRAM actually mean? It means the PSRAM is placed inside the same physical chip package as the ESP32-S3, but it's not part of the ESP32 processor's core silicon itself. Internally, there are actually 2 separate silicon dies. One die is the ESP32-S3 processor, and the second die is the PSRAM memory. These 2 dies are then sealed together inside a single package. So while you are using PSRAM for any requirement, you cannot use these pins for anything else. Alright, so let's quickly verify all of this by actually writing some code. I've already prepared a small program here that does a few simple things. First, it checks whether PSRAM is available or not. Then it prints the total PSRAM size. And inside the loop function, it continuously reads from and writes data into PSRAM. Along with that, I've also included GPIOs 35, 36, and 37 in the code. But for now, and this is important, I've commented out the GPIO initialization. We just want to test PSRAM alone first. Alright, let's upload the code. First, select ESP32-S3 Dev Module as the board. And for programming, we're going to use the USB-OTG port. Connect the USB cable, then go to Tools, then Port, and select the connected port you see there. Now, before uploading, make sure of 2 things. Make sure you enable USB-C DC on boot. PSRAM is also enabled in the Tools menu. Okay, now let's upload the code. Once the upload is complete, open the serial monitor. And here you can see it correctly detects 8 megabytes of PSRAM, and the read and write operations are working perfectly fine. Now, let's go back to the same code and uncomment the GPIOs 35, 36, and 37. We'll upload the code one more time. And now, you can clearly see what happens. The board starts crashing in an unexpected way. So this proves one very important point. When PSRAM is in use, these GPIO pins cannot be used. They are internally reserved for PSRAM communication, and trying to use them as normal GPIOs causes conflicts, which leads to unstable behavior or crashes. Alright, it's very important to note one thing here, that if you want to use the onboard RX and TX pins as normal GPIO, or if you plan to communicate with other external devices using these pins, you should avoid using the UART port for programming. Instead, you can program and debug the board using the OTG port. This way, the OTG port handles all the programming and serial communication, and your RX and TX pins stay completely free for your own applications. Alright, that's all for this video. There are many more things we can cover on this board, and we'll explore them step by step in upcoming videos. Let me know in the comment section what you would like to see next. And as always, thanks for watching this video.